So I'm going to hand over now to DigitalGlobe, one of our sponsors at CARTO locations, and we're going to kick off that presentation with a video. So I will leave that in the hands of the tech team, and Alberto López from DigitalGlobe will be joining us very shortly.
Seeing the Earth from space changed humanity's perspective forever. Today, we see a world that faces challenges on a global scale. But we also see limitless possibilities that once seemed out of reach. That's why we built the Digital Globe, to find solutions to the world's biggest challenges on the basis of facts, not fears. 25 years in the making, this living library of our dynamic planet fulfills our founding promise of seeing a better world. More than just data, it brings together smart tools, comprehensive geospatial intelligence, and human expertise to provide insights and answers. It's accessible anywhere through the cloud and enables critical, time-sensitive decision-making through large-scale computation, data extraction, and crowdsourcing. The heart of the Digital Globe is its massive library of high-resolution Earth imagery, including historical and present-day images collected by our advanced satellites and carefully selected content from other trusted sources. And like the planet itself, it's always changing and adapting. New images, data, and insights are constantly added, making it smarter, deeper, better. There are many ways to tap into the Digital Globe. The up-to-the-minute answers it provides helps us clearly see where we've been and understand where we're going. Humanity has already answered the easy questions. Today's problems will require all of our knowledge, curiosity, and enthusiasm to solve. How can tapping into the Digital Globe help you see a better world?
It seems that doesn't work so well. Okay, hello, good afternoon, everyone. I'm Alberto López, and I'm the last obstacle between here and the lunch that I'm sure all of you are waiting really desperately. We're getting a bit late, but I'll try to be really quick. I'm Global Business Development Director at DigitalGlobe. Maybe many of you don't know who's DigitalGlobe. And I'm going to just try to get you into the concept of what we were the DigitalGlobe. As I said, many of you didn't know who's DigitalGlobe, but we are behind most of the applications you use when you have imagery maps or directions when you order an Uber, so how to get it but just better. Or when you use CARTO, definitely all the nice-looking image you got behind it is DigitalGlobe behind it. But we are also behind operations where we save more than 2,000 people in slavery of fishing in the South Pacific Sea, or providing vaccines in the very remote areas of Africa, or helping the first responders over the different fires like in Santa Rosa in California, where hundreds of square kilometers were devastated inside the cities. Yes, it's a beautiful picture, and it's a nice background, but it's a lot of information in that. It's not just a nice background, and this is where I want to help you to enrich what you do daily. The problem is, let me see if it works, that the world is really huge. It's not just an image. It's just a lot of information in every one of this, but this information is also available in every single image. We're capturing approximately 4 million square kilometers a day, which is approximately 8 times Spain every day at multispectral resolution. So if we collect all that and we throw this information of boulders into the customers, it will not be IT data center that will support it. So what do we do with that? we basically took all these beautiful images, which is 100 petabytes plus. So we're talking about, and growing 25 petabytes per year. We're talking about same size of Facebook videos and pictures that you have today. So it's really huge. But if we got in a data center, basically what we're doing is just stuck them in jail. So how do we access to all that? This is what we really needed to solve. Why? Because, well, everybody wants to have it instantaneously. So we put all this in a tool that can be used by everyone. So we put it on Amazon Web Services. So in order we could take the data out of jail. And as I said before, everybody wants to use it instantaneously. So we have no patience anymore. The same, you don't have patience to get to the lunch. I'm going to go quick. So really, we're doing the same with the images. So we gave access, everybody, to this imagery in a way that when every day we capture this approximately 80 terabytes of information, and we put it in the cloud, we are refreshing the whole world information, and this is available for everybody. Here you see I recorded how the different dots is that people not only viewing and analyzing our data. On the right, you have the percentage of the heat transfer. So it's a lot of data transfer constantly. So this is huge. So when you, for example, want to get a solution for this vaccines problem I said before, and you wanted to deliver this, our colleague Juanjo from Sanita said before how they're doing with the dental hospitals and all that in the cities or in places we know is very easy. The question is when you have to do it in these places or in the middle of nowhere, then things got more complicated. So you need to know where all this population is. And imagine that you have to do it by hand. We're talking about in one stripe, approximately 16 kilometers wide, 100 kilometers long, 1 terabyte of info. The thing is that you have to check all of it. But it's not all of it there. It's hundreds, thousands of stripes. And you need to do it temporally. You need to compare it with the past. So imagine that kind of problem. We have to solve it, just put in these instruction analytics at scale. And when we talk about scale, if we take one analyst and we try to do all this 100 petabytes, even if we take one feature, let's imagine we're going to count cars, just counting cars. It will probably take, for him, approximately 85 years to do it, and we'll get blind. So, okay, forget about it. There's no way to do it that way. So, when we want to extract valuable information, we had to definitely do it in a different manner. And that's the reason why we launched GBDX, Geospatial Big Data Platform. What is a platform that is allowing us to extract information, to transform the unstructured imagery into structured data that it can be exploited together with all the data you use today. So this is not the only source. This is the world-changing environment where where the people, your users, your customers are moving and behaving that you already know pretty well. So with this platform, we provided with a set of tools for everybody to be able to use this. GIS developers, data analysts. So now that this morning Javier talked about the CARTO frames, there's no excuse that why you should not use our Jupyter notebooks to start working with it and solve problem at scale. So all what you do for your neighborhood, now you can do it globally. But how is scale? Okay, when we talk about the scale, all right, let's imagine that we have to solve a problem in Australia. Let's say that we're an insurance company and we want to have a living inventory of what is all the properties that we are underwriting over every year. And we need to do it constantly. Probably you will tell me that's crazy, that's impossible. If we use traditional methods for 7.6 million square kilometers, it will take us approximately 5 years if we can do it. And by that time, it will be totally old. Yes, we can do it, and then we did it. And we did it within the 6 months. We structured every building footprint, every tree, every house, materials, poles, solar panels, a full inventory of a whole country, continent. That's the scale. We discovered more than 2 million buildings non-declared. We discovered so many things that it was not possible to do before. And when you do transition over from the networks from the 3G to 4G to 5G, what you need is really a very updated information. So here we were in inventory of the trees and how the trees could be affecting on the interferences, because this is going to happen with the new networks happening. So it is possible, and it's possible to do it in the whole world. So I'm going to focus on specific examples that you can do and you can transport and give you good ideas of what you can do at a scale. Here you got Gates Foundation to help develop the Mali agriculture. So when we are talking about over there, this kind of problem, we're talking about that a tree is the food for a family for 1 year. So it is important that every tree and every area counts. So we've been able to provide all the tools where the farmers can do analytics, not only what is happening right now, but what happened in the last 20 years, because we recorded all the 20 years of the world changing of a database. And this is available in every inch of the world. Or when we go to Philippines, where vegetation is transforming the country constantly, and we have typhoons, and we got earthquakes, and we got a lot of natural disasters that they're really making difficult the communities to move. When we want to create, or we want to define what is going to be the communication roads, that is, we need to know what is going on constantly. And this is where we put our geospatial big data platform in action to extract every single sediment, every single activity, in the area, to understand what are the roads that has to be built. You all remember what happened with the last earthquakes in the Indic Ocean, where Sri Lanka was affected, and we talked before about the census, how difficult that could be. We're going beyond that. It's just that the census, but also getting with machine learning and deep learning algorithms to understand what are indicators in how we could have this poverty analysis. And that's what we did by understanding all the materials, etc. So when you want to know if you have asbestos in the roofs, then you know that it could be an illegal building. So with this, we created all these indexes that is telling us where the poverty rate and which is the poverty rate, and that can be scaled again across the continent. We talked before about the vaccines, eradicating polio. We did in Western Africa, Somalia, Afghanistan, and Pakistan. There's been a huge problem that we've been helping just to release by deriving population maps at the scales that has not been done before. So here, for example, I put an example. This is Leon, and this is what you have from the INE, 1 square kilometer depth census. This is the reality. So it's 25 meters, grid. So basically, you can do that in all Africa. That's what we did to solve that problem, and this is, how we do that. Or when we talked before about the Santa Rosa fires, Indonesia is suffering fires every year, and we are supporting that, providing not just a beautiful image that will say, oh, it doesn't work this for what I do, Because we always think in an engineering point of view, and we're talking already in the data analytics and mathematical. But yes, we did some analytics. This is what you can see. But we're capturing multispectral imagery that is allowing us to see where are really the fire happening. You guess what? Very few people use this data. Very few. Approximately 95% of all our imagery is never been seen by anybody because it's so much. There is no ball eyes in the world just to do that work. So what we have to do is just to use this as a new method to measure the economic activity, as we're doing with some of the customers. What you have in the background is an image of Madrid, and with a car counting algorithm that is catching every single car in a given moment, instant speed type of car in a given moment. But what if we use it to measure how many cars are produced weekly in the whole world, in all the factories? Or this same image that I said before, here you got Cibeles with all the cars over there. We correlated with part of your data that many of you have just, TomTom out there, you have other data. So that could be correlating this and to know exactly what is happening with the traffic. So yes, you have a good sample, a very nice sample continues, but you probably don't know how many cars you got at 10:30 in the morning on the street of Madrid. I can tell you. All right? So now you have a universe and you have the samples. Let's start correlating. But beautiful pictures are taken. We have a lot of techniques and a lot of algorithms that are helping us to clean the air and to clean the water to have a crisp image that everybody can see, right? But what if you don't throw away this and you use it? Then you have a pollution. And maybe, as you can see here, it's not traffic which is making the pollution be bad. There's other things like, well, check it out what is out there, right? These are the evidences. So we are providing evidences to what you are doing with data you know. So what I recommend, let's put it together so then we can unlock and analyze this. Even in extreme situations like natural disasters. We all know what happened at Fukushima. And what happened at Fukushima, we capture over 14 days the whole of Japan constantly every day. And within 3 hours, we are able to check how many man-made structures have been destroyed or modified. This is really analytics at scale. And when we talk about Katrina, when we talk about Houston this morning, David talked about what happened in Houston with the floods. We are able to do that. We're able to generate automatic 3D at 1 meter resolution accuracy models that allow us to measure this and predict. But also, we can use this elevation together with this changing world in order to improve our networks and to move it forward. So what traditionally has been done manually, and it took 5 years to build a model, and we had many customers complaining that the data gets old and it's impossible to get it updated. Now we can do it at scale, precisely, and with the requirements that we have to. Here you see, for example, Tripoli after the war. Immediately after the war. Are you going to send someone to do data there? Probably you cannot do it. It doesn't mean that you don't have information. Yes, you do. We can provide that. And we provide at scale and can be used in all the different infrastructure rollouts that you can do all over the world. Remember, all we can do in 1 inch, we can do it in every inch of the world. This is what, for example, Facebook is doing with us. Connecting the unconnected. So we can see where is humans, settlements, and activity where there's no internet. And this is what we generated. Basically, where is no internet? Where should I go? And we are supporting the United Nations in all the sustainability goals, all and everyone. I welcome you to help us on doing that. We have an initiative, you will see it later in the video, that you can get in and please don't stay, stop on that. I think it really is worth it. And help us to see a better world. I know that I'm the obstacle. I ask you for 2 more minutes because I'm not an English-speaking native, so probably she's going to do it better than me.
If we want to see a better world, the first step is to see the world better. For 15 years, that philosophy has helped us become the leading collector and provider of the finest Earth imagery ever captured from space. But the ultimate value of our imagery isn't just its quality, it's the information that lives inside it. Insights that can solve pressing problems as never before at any scale. Impacting investors, businesses, cities, even developing countries. That's why we've created an easy, quick, and affordable way to analyze our full collection of real-time and historical imagery. Put geospatial big data to work for you with DigitalGlobe's GBDX platform. Introducing cloud-based access to our unparalleled imagery library. More than 5 billion square kilometers of geospatial data, infinite answers waiting to be uncovered. And to help you find timely, actionable solutions, we've provided a powerful suite of tools. Analyze features of the Earth's surface that you can find, count, measure, and compare over time with stunning speed, accuracy, and clarity. Use our algorithms or import your own. Derive insights and integrate them easily into your projects and products. Create valuable customer solutions without the cost of owning your data. With GBDX, you could measure the growth of cities based on, say, new construction data and the amount of road work performed over time. Or you could evaluate vacant areas to see which types of houses are most or least prone to fire. Analyze variations in local vegetation, building materials, and more. Your findings can boost businesses, assist governments, and save lives. Or combine geospatial and conventional data, such as credit card sales figures, to pinpoint exactly where spending is happening, or project where it will happen. So how will you use GBDX? Learn more today at developer.digitalglobe.com.